As we begin our exploration of data path components, I thought it might be useful to start at the end and explore the arithmetic logic unit, otherwise known as the ALU. You'll find a pre-built ALU here in Miscellaneous Circuits. One of the first things we'll have to do is determine the bit width. For this demonstration, let's set it to 3. Now we're going to put some constants into inputs A and B. So there's input A, set the bit width to 3. Go ahead and join them. Now let's do the same for input B. Now I purposely made an error here. Notice that I get a bit width error. I have 1 and 3. What happens is that the input is 3 bits, whereas I've only specified 1 bit. At this point, it's helpful if you just delete the line and then put it back, and it'll take care of itself. Next, we'll wire the control to our ALU. That will select among the various functions that the ALU can perform. We'll send the output of the ALU to this 3-bit display. Again, I've made an error here. We'll go ahead and delete the line. We'll set the bit width to 3. Then we'll put the line back in. Everything should be good. Finally, we'll make a connection for the carry, and I'll explain what that is in a moment. The ALU performs multiple functions. Let's go through and explore what we have for this particular one. So when the input is set to 0, 0, 0, we see that it does A and B. When the input's set to 1, it does A or B. A plus B for 2. Forgive me, I do not know what ALU stands for. When it's set to 4, it's A and not B. 5 is A or not B. 6 is A minus B. And finally 7 is A less than B. Again, that uses these two inputs. For example, if we set A to 4 and B to 5, well, A is less than 5. So we have a 1 on the output. Here we explore A and B, and you'll observe that I have it set at 2 and 2, and the output is 0, 1, 0. We could say that this performs an AND operation on each column. Here we do A plus B, and this one gets more interesting. So here we have 1 plus 1 is 2, 3 plus 1 is 4, 4 plus 1 is 5, and finally 7 plus 4. But this is where things get interesting. Remember that carry bit I told you about? You'll notice that it just went active. Yeah, you can't take 7 plus 4 and hold that result in a 3-bit system. Instead, you need 4 bits. So here we have the carry. You could think of that as the 4th bit. So the result is 8 plus 3 plus 1, which gives us our 11. Just remember, when we perform an addition, and if our result is greater than the bit width of the ALU, then we will have a carry. Back to the beginning of our video, I mentioned that this was an introduction to data path components. It turns out that the ALU is composed of many individual data paths. One of those is an adder. So when we select, in this particular case, a control of 0, 1, 0, we're activating the adder data path within the ALU. So everything you learned about that full adder is still applicable to this particular circuit.